All right. Good afternoon, everybody. Hope you can hear me okay, Paul. And
Yep.
okay. So again, I want to thank the organizers, Drs. Biggs, Lallman, and Dr. Beck, for inviting me to join you this afternoon on your noontime series. So again, what I hope to address is some of the recent changes in growth promoting use, specifically steroid implant use in beef cattle. And as Dr. Beck said, my very first faculty position almost 30 years ago was as an extension feedlot specialist back in my home state of South Dakota. I did that for 3.5 years and would not trade that experience for anything. I think it's made me a much better researcher and also a much better educator in the classroom for undergraduate students and graduate students having that experience. So what I always used to say in my extension meetings is, try to take one thing home from a meeting that you can apply to your operation. So hopefully you find this as timely information, both from a cow-calf perspective and a stocker perspective of some things you can make changes on in your operation. So a bit of an outline that I'll be following this afternoon. I'm going to just very briefly talk about growth promotion, namely steroid implants and the benefits of those and some of the historical perspectives of the use of that, and then move quickly into the recent changes put in place by the U.S. Food and Drug Administration that basically went into effect July 1st of just a couple months ago, July 1st of 2023. And then to wrap up, I'm going to kind of talk about, with these changes, we still have the ability to use implants in all these different phases. So I'll talk a little bit about lifetime implanting and the impacts of that, both on performance in the feedlot specifically, but also from a carcass standpoint. And so I could spend a whole hour talking about all the work that's kind of been done over the years on lifetime implanting of cattle. But I'll try to be very quick to wrap that up and then have a few concluding comments. So to start with, even though this title says cattle feeding industry, really it's the objective of the U.S. beef cattle industry as a whole, right? We're known for two very important things. We're known for very efficient production and very rapid growth rates on our cattle, all the way from birth through maturity or through the finishing phase on the cattle feeding side. That's what we're noted for, fast growth rates. These are very productive cattle that we raise in the United States. We know they're very efficient cattle. We want very high rates of conversion of feed into growth of mostly edible tissue like muscle. And so we select cattle that have very high muscle to fat ratios as well. On the flip side, as you see on the picture of these steaks, we also are noted for very high quality products, namely meat quality from a high beef quality standard. When we think about palatability traits of those, we know that we produce a very tender product in the United States compared to other parts of the world. We want to do this with minimal back fat. But really the gold standard, and I don't list this on the slide, but as you look at the picture, we're noted for our intramuscular fat, or our marbling development in our cattle. And obviously marbling is very important from a palatability standpoint. It improves juiciness, flavor, and also indirectly improves tenderness. So as you look at this slide, these two things, high efficient growth, muscle growth specifically, and very high degrees of meat quality, namely marbling development in beef, are antagonistic to each other. And so oftentimes what we do from a growth promotion standpoint, we can improve growth rates, we can improve efficiency of growth with growth promotion, namely steroid implants, but we got to be cognizant that a lot of that technology generally has a detrimental effect, especially for marbling development and tenderness of our product. So we're always at trying to do a balancing act of optimizing growth rates, but also preserving that quality of beef that we're noted for here from a U.S. beef production standpoint. So that'll kind of set the table as we talk about these steroid implants that have anabolic activity. So as we think about what are steroid implants, they're really hormones, right? They're steroid hormones. And this slide, just real briefly, I want to kind of classify these steroid hormones into different categories. So when we think about the three major steroid hormones in all animals, both males and females, and in most all the mammals, but definitely in cattle that we're dealing with, we think of the female hormone, that would be estrogens or estrogenic hormones. And of course, the natural female hormone would be estradiol 17 beta. And I show that as a natural hormone. And it's not just in females. Males would also have the ability to produce estradiol as well. There's some synthetic versions of that. Maybe some of the older participants on the webinar today may remember a product that was approved in the 1950s in the United States and then banned in the 1970s. That was diethylstilbestrol, or DES. That was a very potent synthetic estrogen that would bind to the estrogen receptors. And we lost the ability to use DES in the 1970s, in part due to the Delaney Amendment. Another synthetic, or maybe a non-estrogen-like compound that has estrogen capabilities or characteristics would be Zeranol, the active ingredient in raw grow. And I'll talk a fair bit here in a bit or later about raw grow, but that often gets put in as an estrogen mimic, so very similar to estradiol, but yet I don't want to call it synthetic because it's actually naturally produced by fungus species that will produce zearalenone, that is the active ingredient in raw grow. As we move down the list on this slide, on the male side, the male hormones are usually called androgens, and the natural androgen or male hormone in mammals or animals is testosterone. And we have a synthetic version of that that has been used in the United States as a steroid hormone implant since 1987, and that would be trenbolone acetate. So most of our feedlot cattle today, I would venture to say that close to 90% of our cattle in feedlots at some point throughout the finishing phase will probably receive an implant that contains trenbolone acetate. So trenbolone acetate was approved by the U.S. Food and Drug Administration by itself as an implant in 1987. And then really most of the application of trenbolone today is in combination with an estradiol implant or an estradiol component. So that was approved in 1991. The very first implant approved by FDA in 1991 to have both TBA and E2 was Revalor S, and that was approved in 1991 and marketed to the feedlot industry in 1992. The final hormone that often is classified as a steroid hormone and does have relevance to our discussion today and basically beef cattle production, that would be the hormone of pregnancy, or progestins or progesterone. Of course, the natural one being progesterone, and we'll find progesterone as an additive in some of our implants, particularly our calf implants and some of our feedlot implants that would contain both estradiol, also may contain progesterone, especially those that are approved for steers. And many of you may be familiar with a synthetic progestin called melangestrol acetate, or MGA. MGA was first approved in the late 1960s to aid in suppression of estrus in feedlot heifers, but also has been used very effectively as a synchronization tool in heifers for reproductive purposes. So when we think about how do we administer these steroid implants, regardless if we're talking about a 45-day-old calf, for example, a suckling calf, or if we're dealing with grass cattle, stocker cattle like you may do in Oklahoma, or we're dealing with feedlot cattle, these implants, and we'll talk about the different potencies and classes of the implants as we go through this afternoon, but all the implants that are approved today are approved to be administered in the back of the ear of cattle. subcutaneously, so underneath the skin in the back of the ear. And we usually try to put that in the middle third of the ear, as I show on the diagram here on this slide. And this serves many purposes of why we do this. The ear is very vascular, has good blood flow. So the thought is we can easily administer that, right? We can restrain the animal in a squeeze chute, for example, and get access to the back of the cattle's ear. And so we can fairly easily administer these implants behind the ear. But once they're in place, as I show on the slide, the picture on the right, the active ingredients in these implants then can start dissolving, and the blood flow in the ear will take them basically throughout the rest of the body. And so that's one of the reasons why they're approved for the use administration in the back of the ear. The other thing that we often don't think about, but becomes a very important part as we move forward, and definitely as more regulations come in play with these implants in beef cattle, that we administer these in the back of the ear, and early in the harvest process, the processing process of cattle, the ears are removed. And again, this is a food safety item where we don't have to worry about consumption of these residual implants by humans, because we know the ears are being removed early in the processing or harvest process in production of beef. And so it offers a food safety guarantee that we can use these compounds effectively to produce safe, wholesome beef in the United States. When we think about steroid implants and their use in U.S. beef production, there's roughly 30 commercially available implants in the United States yet today that have been approved by U.S. Food and Drug Administration. Now, some of these, due to the recent changes that we're going to talk about, some of these may be retired from the list, but as of today, we have nearly 30 commercially available products. By far, when we think about the use of growth-enhancing technologies in the U.S. cattle industry, steroid implants by far are the most widely used and also the most cost-effective. With the current price of beef, as we all know, at record levels, all the way from finished beef to feeder cattle, the return on investment of these steroid implants have never been higher. We might expect close to a 20 to 25 to 1 return on our investment with say a $3 implant in the feedlot could easily return us $75 in value from a carcass gain standpoint today with the current prices of beef. So there are no other tools from a growth enhancing standpoint in the U.S. beef industry that would have that larger return on investments as steroid hormone implants do. And again, as we're going to cover throughout the rest of the discussion this afternoon, they're approved all the way from basically 45-day-old calves all the way out to finishing cattle. And the important thing about all of these 30 products that I talk about on this slide, every one of those have what we call a 0-day withdrawal. And what that means is we could literally implant cattle today, load them on a truck this midnight tomorrow morning, and harvest them tomorrow morning at a packing plant. So all of these products have been proven safe and have a 0-day withdrawal, regardless of the stage of production that we're going to talk about. So really what Dr. Beck asked me originally to talk about is to kind of give maybe an overview of some of the changes that have taken place the last couple of years in regards to the changes that then were put in place here July 1st of 2023. But if we kind of back up a little bit, this all started almost 3 years ago during COVID. So roughly August of 2020, FDA made some amendments or changes to a guidance document that's been around for many years in the industry, guidance for industry number 191. And this just doesn't have to do with beef cattle. This would do with all food animals that are used for food production in the United States. And so this guidance for industry basically, as I'm going to go through, classifies different stages of production for different classes of animals where we would have approved products, either medicated feed additives or in this case, steroid implants that have been approved by the US FDA. And we knew, so this happened, changes kind of happened August of 2020 is when the federal agency or the US FDA started making changes to this 191 document. But many of us, really since the late 90s, we knew FDA had on their radar that, so most all the products that have been approved to be used in beef cattle production, specifically mostly feedlot implants, many of those up until this change of that happened in July 1st of this year, we were re-implanting cattle that was really not part of the label. And this has been going on since the 1950s when the first implants were approved by FDA in the mid-1950s. And so we only had a handful of products through that timeline of the 1950s up till today that actually had approval on their labels, had a label verbiage that allowed for the use of that product in a re-implanting situation. And I'll talk about that as we go through the discussion. So the whole industry had been doing this for years. And really, in many ways, it would have been considered extra label usage because it was not a part of the approved label to do this. We got further concerned that FDA may have be making changes to this policy when Merck Animal Health in 2017 had two products approved weeks apart from each other. February of 2017, Merck Animal Health had a Revelor XH product, which I show the label here on the slide. And they also had a product called Revelor XR that were approved within a couple weeks of each other. And unbeknownst to Merck, the US FDA or Food and Drug Administration put that statement that I have in yellow on the labels of both of those products, which basically states this product is approved, but it's not approved for repeated implantation, nor can use any other implant in a re-implant program with this particular product. So this was in 2017, which was actually 3 years before the start of the GFI 191 document. And so this kind of set the precedent already in 2017 that there were going to be changes occurring on the implant front for US beef production. So let's talk a little bit about this GFI 191. And this really set the stages of putting different classes of production classes for food animal production in the United States. And first off, I want you to understand that this document just does not cover beef cattle. This would cover all species where we would have approved antibiotics, approved medicated feed additives, as well as implants. Within cattle, the agency or FDA, CVM, identifies three major subclasses: veal calves, beef cattle, which we're going to talk about this afternoon and have been talking about, and also dairy cattle. And so again, we're going to focus our discussion with implants around beef cattle because they're only approved for use in beef cattle. So within that, I'm going to talk about 5 different variants within this document, this GFI 191. I'm going to talk about 5 variants that have implication to beef cattle production, but more specifically, the use of steroidal implants within these different classes. So as part of this new Guidance 191 document, FDA set out that beef calves, they used to be called suckling calves. They kind of changed the verbiage, and now they're classified into 2 different categories. Beef calves of 60 days of age or younger, less than 2 months of age, and these are considered pre-ruminating, and they're nursing. They're still suckling, but instead of the term suckling, they changed it to nursing, basically from birth until 2 months of age. Then they added a second variant, a second classification, is beef calves 2 months of age or older. We assume that these calves are still nursing their dams, but now their rumen is starting to develop. So FDA considered these as ruminating animals within this classification. The other three variants have to do with post-weaning. Okay, so we talked about the two calf variances. The first one of these are now called beef steers and heifers, where they often get broken by sex, either steers or heifers, and that becomes relevant as we talk about different implants that are approved for different types of animals. The first one of these is growing beef steers and heifers on pasture. So another term would be stocker, feeder, or it could be grass-fed cattle all the way through slaughter. But these animals would get most of their nutrition through grazing grass or pasture production. Obviously, very important in Oklahoma. Your stocker industry, I think, is one of the best in the world, and also on the cow-calf side. But this would definitely be grazing or growing cattle in a stocker operation. So that's another variant. Right below that is a classification that drew a lot of attention the last couple of years and has continued to draw attention. And that is what we call growing beef steers and heifers in a dry lot. So this would be cattle, as you read the definition, a dry lot is weaned. So these are weaned steers or heifers. So this does not include the cow-calf sector. So weaned growing beef steers and heifers that are maintained in a dry lot. So this is not actively growing vegetation or grass, but they're being fed a diet of high roughage, harvested forages, silages, for example, harvested hay, possibly with a supplement. And my definition of this, where I grew up in Northern Plains in South Dakota, we would start assembling grass cattle for the summer turnout in February. And for example, in February in South Dakota, there's only one color you see on the ground usually, and that's white because of all the snow. So we would start assembling these grass cattle in kind of a large confinement area, but they would have a large square footage per head. We'd feed them a very high roughage diet to kind of rough them through the rest of the winter, and then turn them out in mid-May, for example, in the Northern Plains. So I think that would be a definition of a dry lot. The last variant, and this is one that drew a lot of attention early on, is that as you read the definition of variant 3 for beef steers and heifers, this is growing beef steers and heifers fed in confinement for slaughter. And so this includes two very important areas. It could be a grow yard. So this is growing and finishing together. If these animals are in a grow yard, but they're in confinement and intended for slaughter, not for breeding, that is the same as if they're already in a finishing yard. So FDA would have lumped a grow yard and a finishing yard as one. And so the important thing is, of these 5 variants that I just talked about, basically FDA still allows implanting in every one of these, as long as the label is put forth that allows a particular product to be used here. So the caveat is that we can still implant cattle that are nursing, and I'll talk about the implants that are approved for either 45 days or 60 days. We can still implant cattle grazing, could get another, so we can implant a calf that's nursing with one implant. When that calf is weaned, maybe it goes into a dry lot, it could get another implant. It then goes on grass in a stocker operation, it could get a third implant. And then it comes into a grow or finishing situation, fed in confinement for slaughter, it could either get 1 or 2 more implants. So an animal, we can still re-implant animals through these different phases, but within one of these variants or phases, production phases, we have to make sure that the label is very clear that we can use that product And if we can reimplant, it has to be stated on that label as well. So now I want to fast forward and kind of take you through what was approved July 1st of 2023. So right after July 1st, we knew these changes, we were going to lose the ability to reimplant cattle within a given phase unless it was on the label on July 1st of 2023. Shortly thereafter, FDA came out with a document. This is publicly available. I just cut and pasted right out of their document onto my slide so anybody can have access to this document. It's on the U.S. Food and Drug Administration's website, but they broke out what was approved for different categories. So let's start with beef calves, and I'll come back to component here. These are the trade names of products that were approved for beef calves. And it's interesting because we have a little bit of variability of different products getting approved for different timelines. So as you remember, FDA had two variances. They basically broke it out into less than 60 days or greater than 60 days. And so here you can see, for example, raw grow, a very common product. It's approved for calves at 2 months of age. Both steers and heifers are all beef calves greater than 2 months. But if you look right below it, another very common popular implant in suckling calves, Synovex C, it always was approved for 45 days. They were able to keep that on the label. So that would be the very first phase. And basically you could give a Synovex C at 45 days of age. And if I go back a slide, component EC, which is a bioequivalent to Synovex C, is also approved for 45 days of age. A couple other products you may be familiar with, Compudos and Encore. These would be Elanco's products, a little longer acting implants that have been on the market for a long time. These were approved for calves, but only for steer calves 2 months of age or older. So that would be kind of that variant number 2 within the calf, similar to what we talked about with raw grow. Now, if we move on and talk about grazing cattle, there's many other implants that are approved for grazing cattle. So these would be weaned beef cattle, steers or heifers. So they have to be weaned, and then they have to be on pasture or grass for the majority of their nutrition. And you can kind of look through this first page. We'll come back and talk about component TEG in just a second. We've already talked about Compudos, but the interesting thing about Compudos is, again, even on pasture, it is only approved for steers. It is not approved for heifers on grass. So you can only use Compudos and Encore on steers greater than 400 or weaned steers, in this case Encore, for up to 400 days. So a couple other implants here. We've already talked about raw grow. Raw grow also made the list for stocker or grazing cattle. Revelor G and Synovex 1 at the bottom of this, and component TEG from the previous slide. These are implants that contain trenbolone acetate. So I talked about trenbolone acetate earlier being synthetic androgen. These would be lower doses of trenbolone acetate. And you can see that, again, you can use these products on grazing only in steers or heifers in the case of Revelor G and Synovex 1. Some things that kind of shocked a few people when this list came out. For years, Synovex S, which was approved for steers, the very first implant approved in 1956, and Synovex H approved for heifers, Synovex S and H did not make the list for stocker cattle. So it's no longer legal to use those products in cattle that are grazing. You can still use them in feedlot in a confinement situation, but you cannot use them for grazing situations. Now let's move on to the third category that I kind of talked about, the dry lot situation, the kind of the production phase that caused a lot of conversations. We talked about what was a dry lot. And it was really not an issue leading up to July 1st because we had no implants that were approved in the dry lot. But then prior to that July 1st announcement of these different phases, Merck was able to get an approval for raw grow for the dry lot. So now, so far today, we can use raw grow in suckling or nursing calves greater than 60 days of age, nursing their dams. We can use raw grow on stocker cattle. And now if we define a dry lot of cattle, maybe prior to going to grass, that they can also receive a raw grow. So in essence, if those cattle went through the same animal went through those 3 phases, they could receive 3 different raw grow implants, for example, 1 nursing, 1 in the dry lot, 1 on grass, for example. So I want to kind of wrap up by talking about some changes on the feedlot side. So as I stated previously, when US FDA, when the Food and Drug Administration came out with this GFI 191, they put basically growing and finishing cattle into one variant, that anything destined for slaughter, fed in confinement, regardless if it was a grow yard or a finishing yard, they could only receive 1 implant unless there was changes made to the label that allowed reimplanting. And as of today, Zoetis has made some label changes. And so for finishing cattle or cattle in a grow yard or finishing yard, we now have 3 different choices. We could use a product called Synovex Choice, which is a TBA, a trenbolone acetate estradiol implant, followed by another Synovex Choice 60 to 120 days later. Or we could use a Synovex Choice followed by a Synovex Plus, which is a little bit more aggressive implant, 60 to 120 days later. Or we could do a Synovex Choice followed by one of Zoetis's longer acting implant called a Synovex 1 feedlot. So Zoetis was able to get these label changes about a year ago, and they're in place today. So producers would have this opportunity to still reimplant in a grow finishing situation. Prior to that, an implant we've talked about already this afternoon, Synovex S, they back when it was still Syntex, now Zoetis has all the Synovex lines, but in the early 1980s, we did get an approval for Synovex S to be reimplanted following either a Synovex C or an initial Synovex S. And interestingly, this label reads for both stocker and feedlot cattle. But again, as I've already stated, we no longer can use Synovex S or H on grazing or stocker operations, but we can still give 2 Synovex S's in a grow yard or a finishing yard, like this label was first approved in the early 1980s. So we could give a Synovex S and then 70 days later reimplant with another Synovex S, which would be an estradiol benzoate progesterone implant. So to wrap up, I just kind of want to talk a little bit about lifetime implanting. So there may be some confusion around these FDA changes about the ability to implant in different phases. And so one of the big take homes from today's discussion, hopefully you now understand, we can still implant in those 5 different phases I talked about. Basically 4, if you kind of put all the nursing calves into one, either 45 days of age or 60 days of age, that's 1. We can then implant a second time on grass with an approved implant. If dry lot fits into your operation, a definition of a dry lot, you can use a raw grow implant there. And then you could theoretically use up to 2 implants in a grow finishing, because I talked about the approval of some of the Zoetis line implants, the Synovex line implants. So theoretically, an animal could still get up to 5 implants throughout its lifetime. So lifetime implanting is still relevant. So I get a lot of questions, and I know Dr. Beck had asked me to kind of address this as I wrapped up today. our general thought is we always want to increase the dose and potency as we go across. If we apply implants in different phases, we want to start with a very low dose, low potent implant. And so if you look at those calf foot implants, like a Synovex C is a low dose estrogen implant. Rolgro would be a low dose estrogen implant. And we probably don't want to get, I've done a lot of work over the years with Trenbolone acetate, and I feel we got to really be careful about use of Trenbolone early in the animal's life. And we definitely want to use a low dose product like I showed you. Revlor G was 40 milligrams of TVA and 8 milligrams of estradiol, for example. So we want to kind of stair step our dose as we go through these phases, as we push these cattle into the feedlot towards a finishing phase. And so most of our more aggressive or potent implants, we definitely want to save for the cattle in the feedlot when they're on a high energy diet. The one thing to keep in mind, though, is by use of these implants, even in a calf, if we castrate a steer at, say, 30 days of age prior to turnout, and so we have a steer calf and we implant at 60 days of age, the one thing that we're going to do is we're going to have a positive impact probably on the frame, the growth of that calf, the frame size of that calf, even when it's nursing. And that's going to allow us to kind of extend that growth potential of that animal. And so as it goes into the next phase, it has more potential growth potential because we've altered the frame and extended that growth curve of that animal. So these products are truly additive from each phase. And so the one thing that is clear in the literature from lifetime implanting is that we will accumulate carcass mass, and that carcass mass is maintained all the way to when we weigh that hot carcass weight at harvest. So we're going to carry all the growth that we get in each phase. That animal's going to carry that growth to the next phase. And they're going to continue to respond to the implant. Now that magnitude of response may actually come down a little bit if they've been implanted before with something similar. And that's where I talked about we want to be cognizant of increasing dose and potency as we move through. But I understand that we're never going to lose that growth, that we're going to accumulate that carcass, that carcass weight, that growth of that animal that was accumulated in one phase is going to be carried forward to the next phase. And so lifetime implanting, most all the literature shows very positive responses of basically causing these animals to carry that weight, stay heavier through each phase. And so in the end, we're going to have a heavier carcass by use of lifetime implanting. So to wrap up again, just some concluding comments here this afternoon. I want everybody to understand that changes went into effect July 1st of 2023, but we can still use implants in all these different phases I talked about. I went through the approval process of a nursing calf, a grazing steer heifer, a dry lot situation, and then a grow finishing. There's only one phase that has approved reimplant labels, and that would be the grow finishing. The Zoetis labels, either the Synovex S label that we talked about that's been around since the early 1980s, or the new Zoetis label changes for Synovex Choice, Synovex Plus, or Synovex 1 feedlot. So the grow finishing phase that we talked about is the only one that has an approved reimplanting label for it. I think we're gonna learn a lot from this change. As I talk about lifetime implanting, I think we're gonna learn a lot now. We'll have a much more finite selection of implants that we can use in each phase. And so we should learn a lot more about this lifetime implanting over the next couple of years. And the last thing I always talk about is there's a lot of debate between non-implanted, the value of non-implanted cattle compared to what I call conventional beef, where those cattle would have received a growth promoting implant. I'm not advocating one thing or the other. if you're in the production, and if you're producing natural beef, that's we have a niche market for that. We have a market for that. I just challenge producers, always know what your cost of production is and make sure that you're obtaining enough premium for giving up technology choices like steroidal implants. As long as you're making enough money to break even or to get a premium above that, that's great. And more options for U.S. beef production and consumption of our great product. But I grew up in the beef cattle industry. I've been in it my whole life. I continue to feed cattle. I grew up in South Dakota. I sat in a lot of sale barns and continue to sit in auction markets. A $5 a hundred premium for non-implanted calves weighing 500 to 600 pounds today is not enough money for what you're giving up for basically 15 to 20 pounds of advantage, even in a nursing calf, at coming in at 500 to 600 pounds with today's feeder calf market. That extra 20 pounds of weight, 15 to 20 pounds of weight by using the implant is worth $60 compared to $25 or $30 premium for not implanted. Now, if they're paying you more of a premium for not implanting those calves or stock or cattle, again, it's real easy to do the math to see if you're at least breaking even, but at least know what your cost of production is, as well as what your premium, what you're getting for a value, a premium value on those cattle for not using technology to make sure you're at least breaking even. So again, I appreciate the opportunity to have this discussion this afternoon. It's something I'm very passionate about. As Paul said, I've worked my entire research career looking at implants and still very passionate about that technology as well as the U.S. beef industry. So Paul, I'll turn it over to you. So.
Thank you very much, Dr. Johnson. I've got a few questions here. The first one, I think you probably already addressed this a good bit, but I have a producer that questions the reimplant between phases of production. That's not tied to a change in ownership. That's only if you retain ownership, but you switch phases.
Okay. So that's a great point about phase of ownership, or the chain of ownership. I should have brought that up. There was a lot of misconceptions early on that, well, as I sell these cattle either through an auction market or direct into a grow yard, that the clock, so to speak, starts over. That's simply not true. The change of ownership has no bearing on the ability to reimplant one more time. You cannot do that. So basically, you have to look at the animal regardless of who's owning it, and use the implants that are approved within that production phase. So if it's a cow-calf producer that asks a question, they can choose from that list that I showed within the nursing side. But then if they sell those cattle, as they go on into a grazing situation, for example, those individuals will have to abide by that phase of production. So regardless of the change of ownership, that does not reset the clock, so to speak. You have to abide by the rules within the phase of production.
So a producer giving a pre-weaning implant weans those calves, puts them in a dry lot, they can implant with raw grow.
They could get a raw grow, and then if they went to grass, they could get yet another implant. So, say up to 650 pounds of age, weight of age, those animals could still receive 3 implants. So.
Got a question. What implant can be used on heifers and bulls that are retained for breeding and replacements?
Okay, so let's start with the male side. There are no implants approved on the bull side. If there's any chance you're going to retain, so if you have non-castrated animals suckling, I would not. There is no approval, and I would not implant them. I think on the heifer side, there's been a lot of work done with these. Raw grow, for example, and Synovex C, I think you can get by with one of those in a nursing calf and still probably have a functioning heifer. That is, if you look at why Compidose and Encore is not approved for heifers, both on the nursing side as well as on the grazing side, it's because these are longer acting potent estrogen implants, a little more potency, a little higher dose. They can interfere with reproduction. So personally, back in my extension days, if you had any thought of retaining heifers or bulls, definitely bulls. You do not want to implant the bulls. But even on the heifer side, if you were quite certain that some of those heifers could be going back in from a reproduction or back into the cow herd, I choose not to implant those because it's just not worth the risk, I think, of potentially having some sort of disorder. But again, you guys are much more experts on the cow calf side and heifer reproduction, but you can use a couple of these in heifers once, and that is approved. So
and this question here is very tied closely to a lot of my research interest. We started working with some long fed beef on dairy calves a few years ago. And through that, as we're calf feeding, they're getting at least 4 implants through our production phase. So I've got a question from one of our attendees. Can you guess or think of a way we can create a long-term implant strategy for these long day dairy cross calves?
Yeah, and I didn't know how many questions like that I might get. That was obviously one of my take-home messages was the long, that class of animal, the dairy influenced beef on dairy animals, in the eyes of FDA, when those calves, first off, the FDA is quite clear is that a dairy influenced animal. Now, if it's beef on dairy cross, a lot of people are saying, well, we know that on day one that it's not destined for milk production, right? But FDA has been very clear is that a dairy animal does not become a beef animal until it's weaned. And so that would mean, most of these people are castrating these calves at 21 days in the hutch or even sooner. So I think there's a lot of people are just thinking, well, if they're castrated, they're steers, or if they're beef on dairy cross heifers, I know we're not going to milk those, so they're destined for beef production. So I think they're applying one of the calf, the nursing implants, right? That variant 1 in the hutch, and that's probably legal, but technically in the eyes of FDA, if it wouldn't be legal if they haven't been determined to be beef animals yet. But I think if you've already castrated them, obviously they're destined for beef. In the eyes of the FDA, they view once those calves leave the hutch and go into what we call the run pens at a calf ranch, they view that as a grow yard. And so in theory, those calves are 80 days of age, probably weighing, basically 250 to 260 pounds. In the letter of the law, they can only receive 1 implant or 2, depending on if it's got a reimplant label from that point on. So that's the phase, that's the type of cattle that we're going to see a tremendous amount of research, I think, the next couple of years, trying to figure out how to maximize performance on those beef on dairies. So.
One final question. This may take a little bit of time to address. That's why I left it to last. It would be interesting to hear your take on the safety of implanting technology in terms of human health when consuming implanted beef versus non-implanted or all natural.
I saw that on the chat here. It looks like that's from Dr. Lauman. So, I'll get on my soapbox a little bit. When FDA, one of the reasons why they made these changes. When some of the pharma companies would have asked the agency, why are you concerned about changing now? Two things always came up: environmental concerns, and namely TBA in the environment affecting aquatic species. That's always been on FDA and EPA's radar. But then the second thing they talked about was the food safety aspect, human food safety. The last 10 years, I've been involved in a lot of anti-doping work done on the sports science side, where there's a lot of high-profile athletes that fail, say, a trenbolone test, which is available on the black market, and they'll blame it on meat consumption. The truth of the matter is, we've had trenbolone acetate in the United States since 1987. We've had zero, and I mean zero, violative residues of TBA since 1987. So it's a very safe compound. Part of that is what I talked about, putting, as long as we apply them properly in the back of the ear, that adds to the food safety aspect. So when we look at the residues of what I talked about, the zero day withdrawals, we could give it today and ship them and harvest them. The level of residue in the meat is extremely low. And furthermore, when we consume that meat, our human GI tract, these steroids are the reason another reason why we got to implant them is they're not very orally active. And again, females understand this. If they've ever taken birth control, for example, those compounds are derivatives of naturally occurring estradiol and progesterones, but they have to basically change the structure of these to make them orally active. So we do not absorb these steroids. Any residues that might be in a steak or ground beef, we don't do. Our body is not very efficient at absorbing those into our system, into our bloodstream. So that just adds another safety element to them. And so, yeah, we can detect differences. There's a lot of research showing, if you just want to look at estradiol in an implanted steak versus a non-implanted, there's a significant difference, but it's biologically irrelevant, is what I say. Those numbers are so small in both of them that they would not have any kind of efficacy or biological effect in humans. And so I challenge the agency a lot to say this is not a food safety aspect, because we've never had issues with steroid implants in the United States from a food safety standpoint.
Excellent. With that, I'm not seeing any other questions in our discussion. Anybody of our attendees, if they have questions, feel free to type them into the webinar chat or the Q&A. Also, please complete the feedback survey that was just posted on our chat as well as you exit.
All right, Dr. Beck, I'm not seeing any additional questions in the chat or the Q&A. We'll hang on a couple more minutes. Just as a reminder, the recording for today, as well as Dr. Johnson's slides, will be up on beef.okstate.edu probably sometime next week. And so if you missed an option in this series and you want to catch up, you can check those out there, or any of the other recordings we've had for the last couple of years. All of that again shows up on beef.okstate.edu. We do want to reemphasize, if you joined us last week, you heard again about our ongoing internal parasite research study. And so if you have cows, calves, groups of cattle, and you're interested in participating in that, you're certainly welcome to send us a note. Dr. Beck, myself, Dr. Lawman, and we'll get you connected with that. And also that appears in the feedback survey too. You can enter your email there and we'll send you direct information straight to your email. So Dr. Beck, have we forgotten anything else?
No, I believe that captures it all.
All right. So on behalf of Dr. Beck, Dr. Lawman, and myself, thanks so much, Dr. Johnson, for joining. It's really great information, timely, and I think from our attendance today is very pertinent to everyone in the industry. And with that, we will sign off. We will see you again in the Rangers Thursday Lunchtime Series, probably in a couple 3 months when we get the next options put together. And so if you're interested in certain topics, if you'll just list those in that feedback survey, we will consider those. And we're very fortunate to have experts like Dr. Johnson join us from around the country, as well as sharing the expertise right here at OSU. So with that, I hope everybody has a great day. A few more days of hot weather, and then the state fair is starting, and so that always means it's going to cool off, and hopefully there's some rain with that too. Maybe not for our state fair exhibitors, but certainly for the rest of us. So thanks again, Dr. Beck. I'll let you close out.
All right. Thank you once again for attending, and we will look forward to seeing you next time we kick this series off.